Welcome to Cassandra Lunch number Data Engineers Lunch number 111. Don't forget to like and subscribe, as well as turn on the notification bell so that you can get notified every time we post a video or go live. Today we are here with Ryan Day, an advanced data scientist at Conference of State Bank Supervisors. He is the author of an O'Reilly hands-on API for AI and data science, which will be released in May of 2025. And he's here to share some practical tips for making APIs that data scientists will love. The co-organizers for Data Engineers Lunch are Rahul and myself. If you are interested in being a co-organizer and want to help get speakers by reaching out to people in the Cassandra community around the world or the data engineering community around the world, please drop an email to me or this marketing email listed below. If you want to give a Data Engineers Lunch or speak at our sister event, Cassandra Lunch, please feel free to reach out to me as well. We are part of a larger community called Data Community DC, which believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome, and we expect respect to be given to all. Data Community DC is actually made up of a lot of different groups generally centered around data, and you can find out more about all the various groups and events at datacommunitydc.org. At Data Engineers Lunch, we cover everything from the ingress and egress of data and absolutely everything in between: databases, ETL, data wrangling, all the tools and processes of the data engineering world. If there's anybody new that would like to say hi, please put your comments in the YouTube chat. And as always, don't forget to like and subscribe. A few rules: if you have a question, please ask it. Ryan has asked me to hold all of the questions for a Q&A session at the end of the talk. So put them in the YouTube chat and I'll get them to him at the appropriate time. Always be polite and courteous to others and share what you know with us. This is a community. Here at Anant, we design, build, and manage global real-time data and analytics platforms surrounding Cassandra, Spark, and Kafka. We also have a burgeoning AI and generative AI practice and work extensively front-end, back-end, everywhere. Thanks to all of our sponsors, including DataStax and George Washington University. Thanks to all of our institutional and organizational sponsors, and thanks to our customers for making this all possible. And if anyone has any job offers or is looking for a job, please drop links in the YouTube chat. Additionally, if anybody has any meetups, hackathons, classes, or conferences that you would like to promote, please feel free to put those links in as well. We have a variety of events that we support. You can always check out the meetup group to see what events are happening. You can also check out Cassandra Lunches on Thursdays. We have a Cassandra Lunch this Thursday where we will be doing a RAG versus QLoRa fine-tuned LLM discussion, where all of the data is hosted on Cassandra, specifically on DataStax Astra. And you can see more about all of our events at anant.us/events. All of our videos are available on YouTube, and you can also check out this Cassandra runbook, the last in our series, at anant.us/runbook. With that, I would like to welcome our speaker for today. Ryan, please introduce yourself and take us away.
Great, thank you. Let me share my screen here. Can you see the screen there okay?
Yeah, that's coming through great. Once you get it, perfect.
Good to go? Right, well, thanks so much for the introduction. Really excited to have a chance to present to the group here today. As he mentioned, I work with an association in DC there, the Conference of State Bank Supervisors. We're off of Franklin Park area, so it's great to share with local folks in the DC area. Here's some information from my GitHub profile. So if you're interested in checking out the code that I'm going to be sharing today, that APIs Data Scientists Love repo is on there. And feel free to take a look at the code. There's not a ton of code today, and you'll have a chance to see how the stuff that I'm demonstrating. Also, I'll share a little bit more about the book at the end, but the content here is information that I've put together while researching the book. You can view more about that on the handsonAPIbook.com. So I'd love for you to check that out. That'll be published next year, but there's a early release available currently. To succeed in AI, I believe that you must first master APIs. So the reason that I'm sharing this presentation today is the way that the industry has developed the last few years around data science and AI, APIs have become a critical skill. And I really believe that to succeed in data science and AI, all of us really need to level up our API skills, which is more than making a simple call or quickly throwing up a model on an API. There's specific techniques to do it in a resilient way that we can learn. And just to make this personal for the folks on the call right now, I believe that if you take the effort to really become the API expert on your team, I make a challenge to become the API expert on your team. I think it's going to make a big difference in your career going forward, and I think it'll make a big difference for your team. So that's the perspective that I'm going to be sharing today. So here is the agenda. We're going to spend a couple of minutes looking at a day in the life of a data scientist, looking at the jobs that they do and the tools that they use with a focus on the Python ecosystem. Then I'm going to spend most of the time talking about some tips for how you can create an API that data scientists will love. So if your target audience of using an API that you build is data scientists, how you can customize that for them. And that's where I'll show the bulk of the coding examples in Python. I'm going to be sharing FastAPI and Pydantic and SQLAlchemy there. At the end, we'll have a few minutes for questions. I'll answer any of those questions that I'm able to, and then finish up with some wrap-up comments and really give some a call to action for you, what you can do next with this information. So what is a typical day in the life of a data scientist? So a few years ago, kind of the joke with a data scientist, we had the term data scientists were unicorns. So the idea that somebody would have all of the skills to create an advanced machine learning algorithm and a data pipeline to serve it, then build out a web application, deploy it to the cloud and in a high performance environment, and that one person needed to have all those skills. Well, the last few years, we see that data scientist job category covers a lot of different areas, many of those as well. But really, my experience has been no two data scientist roles are the same. Hopefully, folks on this call, some of you have a data scientist role, and probably each of our roles is a little bit different than another. But there are some things that we can generalize. And so if we look at the jobs that data scientists do, the Anaconda State of Data Science survey is a really good source for this. And basically, they served working data scientists and asked them how they spend their time, among other things. And so the data scientist time was divided roughly into these three big categories. So the largest amount of their time was spent doing data cleansing, creating data pipelines, data preparation. Then they also spent about a third of their time creating reports, visualizations, and presentations, that type of thing. And then about almost a third of their time doing, preparing, creating training models, deploying models, and all those. So these are kind of the broad tasks that they're doing. And what we'll see is that APIs play a key part in each of those. So in those data pipelines that we create, an important data source that we often pull into those is APIs. So web APIs are a key part of the data sources that we're pulling in and doing the data cleansing on. When we create those visualizations and dashboards and charts and applications and things like this, again, we're consuming APIs to combine with other data sources and to display. And then we look at the machine learning modeling, creating the models and pulling in training data and all that. And one of the most important ways that we deploy a model is by creating an API and exposing an inference endpoint where it can be consumed by other users. So APIs play a key part in all these areas of a data scientist role. So if we look at the tools that data scientists use, I'm going to focus specifically on the Python ones. I'm going to go from left to right this time. So in that modeling, machine learning modeling area, data science will be using tools like PyTorch, like scikit-learn, and many others there. They'll be deploying those models with frameworks like FastAPI, Flask, and some of these others in that Python area. When they look at creating those reports and visualizations, they'll be using libraries like Seaborn, some of the new frameworks like Streamlit, Gradio for creating analytical applications in Python. And then that data prep and cleansing. So they're going to do a lot of exploratory data analysis in Jupyter notebooks. And for creating full data pipelines, looking at tools like Apache Airflow and other frameworks like this. So we've met data scientists. We have some idea about what they work. So let's dive in and see how we can make them happy when we create APIs for them. So we're going to look at making APIs that data scientists will love. And the key point here is that API producers create APIs for a broad range of users, but data scientists, when they use those APIs in all those ways we showed, they have different needs than the average web developer. They're using different tools, they have different tasks that they're trying to perform. And so we'll look at how a data producer, an API producer can customize and tune APIs to serve them. So here's these are the tips that I recommend that we make APIs that data scientists will love. So the first is to return data in JSON format. The second is to provide standard external identifiers in the API. The third is to enforce data type definitions. The fourth is to provide a software development kit or an SDK. Fifth is provide a method for bulk downloads. And last is to support querying by last change date. So I'm going to walk through these and explain them and use these as a way to demonstrate the FastAPI API framework. So we'll look at the first one. Return data in JSON format. So, when you build an API, there's going to be a lot of technical decisions that you're going to make. You'll decide what platform that you created in, what architectural style, such as gRPC or REST or GraphQL. You'll make a lot of decisions like this, and one of them is the data format. And so, really, this should be the easiest decision for you to make when you create the API, is that you should provide it using JSON. And so before we look at the code, and I'll show the way that you do this in FastAPI, I'm going to give you an overview of the architecture of the API I'll be showing you. So from the user's perspective, when they call the API, they're going to be interacting with the Unicorn web server, which is an open source web server. And then they're going to be sending and receiving JSON messages back and forth across HTTP. They'll be interacting with Pydantic. The Pydantic library is a Python and it's a Python library that's actually built in Rust, very high performing, the new version of that. And so that performs validation of data. It also performs the serialization and deserialization, converting data back and forth from JSON into Python objects. They'll also be interacting with the FastAPI, which serves as the controller and is tying all the pieces together. And we'll look at those first two pieces first, the Pydantic and the FastAPI. Later on in this one, we'll look at the SQLAlchemy and the SQLite. So let's see if I can do the demo right. We'll switch and do our first demo. So let me see. Should get VS Code up here. All right. So what I'm going to demonstrate is creation of a FastAPI application and show some of these pieces using, again, Pydantic, SQLAlchemy, SQLite backend. And so I'm going to keep it pretty simple. I've tried to, the code that I'm showing is, it's a pretty small API, but hopefully it'll demonstrate the parts that I want. So first that we're going to do is we're going to create a Python virtual environment. So I'm going to run the commands in the terminal inside VS Code here. And then then as we install the libraries, second here, if all goes as planned, then it should be installed here. Okay, so I'm going to start showing the required libraries for the demonstration. So we're using a requirements.txt file and we're going to do a pip install using that one. And so you'll start by having FastAPI, the FastAPI library as your one requirement. And so I'm using version 0.111. This is the most recent one. You can see I pin it so that it will stay on that version, but allow patches as any bug fixes are applied in that one. And so I'm going to go ahead and do a pip install of this. And we'll notice that it ends up 36 libraries will actually be installed. I got to get in the correct library or directory here. Just a second here. Okay, so we're going to do that pip install. And even though we have this single library that we're actually installing, it has several dependencies, and its dependencies have dependencies, and we ended up installing 36 Python libraries. So that's something that we'll typically see when we're interacting with an open source like this one, is that there are a number of dependent libraries that will install. Okay, and then now we'll look at the actual code to create your API. So to create the API, the first one we'll be demonstrating. Again, our tip here is to return data in JSON. So this is the FastAPI file. So it's a Python file. We will import FastAPI, and we will create the app object, which is a FastAPI object. And so this is what makes this Python file a FastAPI API. We'll have one function, which is the root function, which is what I've called it. And we have a decorator of it. And so by decorating this function with the app.get and the slash, this is a special decorator from FastAPI that says this function will be called when the user of the app calls an HTTP GET at the path slash. So this is our base URL that we'll use as a health check. So the information that we're returning here is defined as a Python dictionary. And so, but when the user calls this in a second, we'll see what this looks like. They're going to get a JSON response. And so that conversion from Python objects into JSON is being performed automatically for us. FastAPI uses Pydantic to convert that. And so we will kick off this API. So we're going to use the FastAPI command. So we'll FastAPI, and then we'll do the JSON return JSON.py. I've got to actually do FastAPI dev. Okay, so if you've used FastAPI before, seen some demos of it, you may be used to seeing when you run a FastAPI API using the uvicorn command. The latest release, 1.11, has just rolled out the FastAPI command line interface. This is brand new functionality. The uvicorn command still works, but going forward, this will be the preferred. And so you see that FastAPI command line is looked at our code, has identified this app is a FastAPI application, and has launched it on this local directory. So we're going to take a look and see the JSON there. So I'm going to open up a web browser. And so this health check endpoint that we hit at the root, the slash, that the backslash has returned the message that we put. It was a Python dictionary. FastAPI converted it to JSON. You can tell with the data types here being null rather than none, and true is different. So That is using Python. I'm sorry, that is using FastAPI to return JSON and kind of gives us our introduction to FastAPI. So let's look at our next tip now. Okay, so the next tip for building APIs that data scientists will love is providing standard external identifiers. And these are an external reference to join other data sets. So what do I mean by external? So typically in an API, a lot of times the way they build an AI is that an API is around the internal identifier. So for instance, if you have an API endpoint that sends a list of products, it might give you a list of products and the user gets those, and then taking the product ID from the API makes a callback to get details on a single product. That would be a very typical workflow. And so within your application, those internal identifiers are probably all that you need. But whenever you're providing your data for data scientists, they're oftentimes going to be creating reports or other analytics products in which they want to enrich the data that you send by joining it with other data sets. And so it becomes important that they have the ability to easily join the data in your API to other data sets. And so this is where you look at some industry standard identifiers. Examples of these in healthcare would be a national provider ID. Retail, there's UPC codes, G10 codes, ISBN codes. We see a lot of FIPS codes, ISO codes. And so the tip is to specifically add these external identifiers into your data sets in the API so that you make the job easier for the users to join them, even if it's not something that you need internally in your app. So the rest of the presentation here, I'm going to give an example using fantasy football data. And so the scenario is that you're creating an API and you have a fantasy football website. Now, if you don't know what fantasy football is, it's a hobby where people try to predict what NFL football players are going to score, yards and touchdowns and things like this. It's a pretty big hobby. There's 40 million users in the US. It's a lot of fun. And so think about if you owned a fantasy football website and you're creating an API and you're sharing out with football analysts and other data scientist users. So you would need to figure out what is an external identifier that you could use, for instance, to identify players. And so if in researching this one, it's not an easy topic. There aren't ones that are used standard across, but the best external identifier for players is actually from the NFL's own game statistics and information system. So it's called a GSS ID. And so by adding that GSS ID into your API, as you share out the data about NFL football players, then other people will be able to use that ID to join up to other data sets. So the way that I'm going to implement that is to add the GSS ID in the database that I use for this API, and then push it up through the other layers. So let's look first at what that database structure looked like. So in the player table, you see the player ID that I have, which is the internal identifier and the primary key for my purposes. That's not a standard identifier that other apps or data scientists can use. And so we've added the GSS ID, which is that standard external identifier. And so that will allow us to provide it out in the API. So looking at the rest of the architecture I showed before, that user interacts with Pydantic and FastAPI. The way that the data is stored in this application is it's stored in a SQLite database. And then there's a Python library called SQLAlchemy, which is an object relational mapper, ORM. And what it does is it allows users to view the database objects as Python objects in their code, and interact and query the database using prepared statements through the ORM rather than making direct SQL calls. It also interacts well with Pydantic so that when you pull data from the database, Pydantic can take that data and serve it up to the users. So we'll look at some of those pieces now. All right, so we'll get our next demo. Okay, So we are going to stop the API that's running here. And we're going to go to another folder, which is the provide identifiers here. Okay, and so this is another different FastAPI application. And so in this one, we'll see that there's a number of more files that we've added, whereas our previous one only had really one Python file, a requirements file for installing libraries. We're going to have files in here that handle the SQLAlchemy, and then I'll give more details around Pydantic. So we'll look at those in a second. But let's start with the requirements. And so we're going to install additional requirements here. So I'm going to run this. So we'll do another pip install. So now SQLAlchemy will be installed as well. And then we'll look at the new endpoint that we create. So before we had the health check endpoint, now we've got a new function. And so this function is the read players function. And I won't be able to go in real detail of all the pieces on this, but I'm going to hit the highlights for you. So this read players endpoint, it's got a decorator here that says this is a FastAPI decorator. And so this function will be called when the user does an HTTP GET on the endpoint /v0/players. And so that's the API endpoint, and this is the function that will be called. And so when they call this function, it is going to call the getPlayers function internally, and this is a SQLAlchemy function. So in order to return all the data from our players table, which we saw in the diagram, this is the function. So we'll hand it the database session, and we'll tell it to query the players model. So you can see there's not much code required to set up our queries. Again, that SQLAlchemy has a lot of the built-in functionality. And so what does the player model look like? So this is how we define the structure of the classes that we want to interact with in our database. This is a SQLAlchemy model. And so in this one, in the model, we tell the table name to map it to in the database. So this is actually the physical name of that SQLite database. And so we say this class will be created from the player table. Then we define the attributes on this one, including the primary key, and there's that GSS ID that I mentioned. And so it's going to pull all of this information from the player table. Again, it's being defined here in this SQLAlchemy model. This function here, getPlayers, is a SQLAlchemy query. And then it's going to return it to this readPlayers function. So let's see if that runs, and we'll take a look at that. So again, we're going to do FastAPI dev. By running dev here, what this allows us to do is, as we change code while the API is running, it will automatically receive those updates. Okay, and the Python file that we're running is the provide ids.py. Okay, and so it's going to run this locally as well. And I'm actually going to go to the docs link on this one, rather than going to that root health check endpoint. Okay, so one of the things that comes built into FastAPI, the framework, is that it includes the Swagger UI, as you see here. So Swagger UI is an open source interactive API documentation. It's very common. You'll see a lot of different companies use this with their API documentation. So this comes built in. Swagger UI also has the redoc. FastAPI has the redoc documentation built in as well. You can get that by doing the redoc endpoint. But this comes out of the box. And so in order to then use this, if you want to see that, again, the goal is to see us providing that GSS ID. So we'll hit try it out, we'll see that what's expected here is there's the example schema, is the data is in there in the data. So we're going to execute it. And this is going to hit our database and pull the player information out of it. And so we can see the format of this GSSID. You can see why it's stored as a text field in our database. Although it has numeric data, it has some text formatting in it as well. So again, the goal then is that as someone who is using this player data, they have this GSSID so they can join it to additional steps, additional data sources. All right, so let's go back to our next tip. And the next tip to make an API that data scientists love is enforcing data types. And so why is this a data scientist tip? We should always enforce our data types. That's true, right? So what this basically means is that we're going to define what we say the data types return from our API are. But sometimes you put it in the documentation and then code changes over time and things like this. And if data types don't continue to be enforced, that can cause problems for API users. Now, if the user of it is a web developer who's just displaying some information from your API on an HTML page, the impact may not be very large, right? It's all text to them. If you put text data in a numeric field, or you put it, you don't have a floating point where it's intended, may not be that big impact on a display. But for a data scientist, when we're using information from an API in our data pipeline, if it has those invalid data types, it's going to cause a lot of rework and debugging on our side. Also, if we use it to train models, this information that we're counting on being included, and maybe we're using it for creating correlations or clustering or things like this. If we can't count on that data type, then it's going to make the data a lot less useful to us. And so there's a company called Speakeasy. They had a blog post recently. They use the term type faith. Your user has type faith that the types that you define is what's really going to become when they receive it. And so we want to make sure that we have steps in place to enforce the data types. So I'm going to demonstrate how this is done with FastAPI. I'm going to show you the OpenAPI specification and Pydantic. So if you look at this same endpoint that we were looking at a minute ago, and we focused on the database portion of it, which uses SQLAlchemy. We're going to look at this part up here in that decorator again. And what we've specified is that the response model of this endpoint is a list of schemas.player. So the response model is the definition of what the API user will receive when they call your API. So this is the contract that we're making with them about what they can expect to receive. And it shows in here a list of players, and then the definition of the player, if we go to this is a Pydantic schema or a Pydantic model. Those terms are kind of overlapping here. So this is a Python class that we're creating from a base Pydantic base model. So this is a subclass of that. And by subclassing the base model, we get all of the functionality that Pydantic has for validating data types and also serializing them into Python to send across in the API. So the first line in this, I won't go through super detailed account of this, but this line here allows this object to be built from a SQLAlchemy object. So it pulls the attributes from the SQLAlchemy class we got of the database and prepares them to interact with the user. Then we define those data types as well here. Again, you see we've got that GSSID along with the other information. Now let's show you then what Pydantic does with this. So we're going to look again in the browser. So if you look in our model here, in the API documentation, I mean. So the first thing it does is I clicked that pretty fast, but in the Swagger UI, the OpenAPI specification file is linked here. And so the Swagger UI documentation is shown is generated automatically from this OpenAPI file. So if you look at the structure of this, This explains, this is the definition of the contract that users can expect when they consume your API. And so it defines the paths. So that function that we saw in the code, the path for /v0/players, it's an HTTP GET. And the response model that they can count on receiving, they're going to receive in JSON format. They're going to receive an array of player schemas. And so this is defined here in the definition, and they can see that the player schema has all of these attributes and these data types. So this is by enforcing that one, you saw that I didn't create any specific code that goes in and validates and checks all of the data types to make sure what came from the database is valid and formatted properly before I sent it to the user. Pydantic did all of that. And not only did it do all of that validation, it also generates intelligent errors and explains issues with it. And so again, to the user's perspective, they then, when they look at this endpoint to see what they can count on, so they can see the example, they can see that they're going to get an array of objects with this definition. So that's the way that we enforce that. And you see how much work Pydantic is doing there. Okay, so let's go to the next tip. Next tip is to provide a software development kit. And so I would say this is probably the most important tip that I would give to API producers if they want to provide APIs for data scientists, is that they should provide a software development kit. And an SDK can take many different forms. The term can be used different ways, but most commonly it's basically a wrapper library in the language that your audience is going to use. And so it allows the developers to interact with your API without having to do much of coding themselves and just automatically have the functions available to them in their language. And so the advice on SDKs deciding what language to create it in is go where the users are. And so if your users are data scientists, that means you're going to create a Python SDK, possibly also an R SDK, and that's going to be the biggest time saver for them. And so I'll show you how simple it is from the user's perspective, to use an SDK. And I'm going to demonstrate a company that I think does this really well, which is a company called StatsBomb. So StatsBomb provides sports analytics to teams and agents and analysts. They provide data in soccer and in football. They have a whole analytics platform that teams can subscribe to, and APIs that they can subscribe to. But in addition to that, they also provide a couple of SDKs. So I'm going to see if I can pull this up here. So if you go to StatsBomb, this is their GitHub repository. And you can see that they provide open data. So they have data available for download that's not the most current data. They also then have an R and a Python SDK. And so we'll look at that. This is, if you look at the way that they use this in their business model, they say that this Python package allows users to easily stream StatsBomb data in Python using your login credentials for the API or free from the GitHub page. API access is for paying customers only. So they're able to, they publish the SDK. They also then have a relationship with their users to have paid subscribers that have some of the functionality that others don't. And so I'm going to show you how easy it is from the user's perspective to use this data. So they say to install, use pip install. So just like those other Python libraries that we had, the FastAPI and SQLAlchemy, they've published this SDK on PyPy, which is a package repository. And so if users want to use it, they can use it in the environment that they have with the tools that they're used to. So I'm going to use a Jupyter Notebook, which is one of those tools that we mentioned that data scientists use. The environment I'm using in is a Google Collaboratory, Google Colab. And so from the user's perspective, it's interesting to point out when you talk to data scientists, they don't care about your API. And this is a little disappointing if you're an API provider. but they just want your data. So data scientists, like, we just want your data. We don't care how we get it. And so we need to have it in the language that we need it in this case, Python. So they will go and they will, I've already run this here. So, well, I disconnect. I better run it just to be sure. So they'll just go and they'll pip install. So they're going to install StatsBombPy. It has some additional dependent libraries you see here. And then they will then go into their Python code. They're going to import it. And then they can just run a function on the SDK. And they've got data from competitions. So if you think about, again, from the user's perspective, there's several steps of having to interact with your API that are skipped here. So they don't have to, one, know that it's an API. They don't have to go find your API documentation. They don't have to find the production endpoints or all of those things. Again, this is one where they have to get to the live data, they'll have to eventually have a relationship with you, but free data is available out of the box. So this is why I call this an easy button. And so that's the benefit of an SDK. So let's go to our next tip here. Next one is providing a method for bulk downloads. So if you think about one of the tasks that we showed that a data scientist wanted to perform was those data pipelines. And so oftentimes, if they're going to use your data on an ongoing basis to update their data sets, then an initial step that they're going to perform is they want to get an initial load of all of your data. Now, API providers don't want people to do a full hit on their API to pull down all the data. It's very resource intensive. They certainly don't want to be doing it frequently. A lot of times they'll actually put in pagination limits to prevent people from getting more than a few hundred or a few thousand records at a time. And so enterprising data scientists will find a way around all of that with recursive loops and all this, right? But to avoid that, just by providing a method for bulk downloads, you're saving a lot of time. I'll also mention data scientists are different. Even the first time that they want to see data, they're different than a typical web developer. So a lot of times as a web developer, if I'm creating a web page and I want to just look at the contents and API, I might just look at a few samples of it, kind of get a general idea, and then put it in a web page, some kind of pilot or prototype to see, what data is on it, what it looks like, and how you interact. But a data scientist, if you're in that exploratory data analysis stage, even from the very beginning, it's likely that you want to pull down the whole data set, do some exploratory data analysis against to find out, any nulls in it and find the different distributions of data, all these things. And so they immediately want to get this whole data set. And that also, again, in that ML modeling stage that data scientists perform, they want to take this data and pull it in for training a model. They're going to take it and break it up into a trained data set and a test data set and a holdback data set. And so they want your data. They don't want to just get a sample of it. So by providing this bulk download method, you're going to serve their needs, and you're also preventing yourself from getting accidental DDoS attacks against your APIs when people are trying to get your whole data set. So let's look at how StatsBomb does this. If you look at their Python library, and this is just one strategy that you can do with this, but it's very interesting. So I mentioned that there is an open data set. These are bulk downloads. In this case, it's not the most current data, but you can imagine how you could implement this similarly for even the most current data. Bulk download files are available just directly on in JSON format on their GitHub repository. So that's a method that's available right there, is to just go and download them off of an open data repository. What's really slick is in the Python SDK they created, they have the ability to either pull the API data to get content or to pull it from those actual open data sets. So if you look at their config of the SDK, they have the path to those open data sets that are the full bulk downloads. They also have the path to the actual API endpoint. And when the user interacts with their SDK, they can look and see if that they're a client with credentials, then we'll give them the data from the API. If they're a user who isn't logged in, then we'll get it from that competition's open data set. So that's one method that you can use to provide bulk endpoints, bulk downloads of your data without having to provide it through your API, which may not be tuned for that. Okay, and this leads us to our final tip, which is, looks like we're getting pretty close on time here, so we'll cover this one pretty quickly. Last one is support querying by last change date. So this is a follow-up to number 5, the bulk download. Again, if you're building that data pipeline, you want to start with a bulk download, but you don't want to have to get a full bulk download every time that you run an ETL or ELT process. You don't want to have to run a CDC and all those things. There are definitely ways to do that. But ideally, what you'd like is just get the deltas, meaning just get the records that have changed. And so by supporting that in the API, then you can allow them to start with a bulk download, and then in a recurring job, they can say, when the last time they ran their job was, and just give me data that's changed. And I'll make one key point here about a last change date. This is a technical column rather than business column. And what I mean by that is that there may be new transactions that come over time, and you might have a transaction date or something like that. And so by default, it's possible that you might already have this supported with a business date. But the last change date is technical in nature, meaning if any previous records have been changed, updated, corrections have been made, they want to receive those as well for their data pipeline. And so by adding that last change date technical column in your API, it allows them to continue to keep that fresh. So real quickly, I'll show you what that looks like in the example API I was showing you. So I'm going to go ahead and open up the oven with the finished product here, and we're going to look at a fuller version of this API. And so if you look at this one is based on the same one that I showed in the examples, but it has a large number of endpoints, a lot more information and enhancements and parameters that you can send and things like this. But again, going back to that, we'll show it actually with the performances data. So performance is a player that scored in a game. And so we see that we have added some parameters to this. We have a skip and limit, which is how we will implement our pagination. And so we'll say we don't want to be limited. We're going to be able to pull 1,000 records. And this is that minimum last change date that we've added. And so we'll add this one here. And I'm going to put a date of April 1st. I'm going to make sure that I get my formatting correct and execute it. And when the API runs, then it's going to filter down. This is the endpoint. You can see what was executed. Did performances. I'm sending query stream parameters, which include the last change date. And then the data that's returned is going to be only the records that have changed since that last change date. So again, this allows that the recurring ETL, ELT processes to run after it's been initiated with a bulk endpoint. All right. So just to recap those tips that I shared, to make APIs for data scientists, you want to return data in JSON format, provide standard external identifiers, enforce data type definitions, provide a software development kit or SDK, provide a method for bulk downloads, and support querying by last changed date. And with that, I am ready for a Q&A.
Great. So Ryan, we do have a fair number of questions in here. I'm going to scroll back up to the top. We're going to go sequentially from when they were asked. So
should I stop sharing, or how would you like to?
Oh, you can leave it up there or take
Okay,
it down,
great.
however you prefer.
I'll just leave it there.
So starting with the first question here, did you spend any time talking about your approach to securing access to APIs, so making sure only certain folks can get access to the data?
No, I didn't address that in this demonstration. Yeah, so
Mhm.
I just showed the functional on that one.
Yeah.
I would recommend the people look at the OWASP guidelines for API security. I will mention that one item that is in here that is addressing security is that by using SQLAlchemy prepared statements, it
Mhm.
it does protect against SQL injection attacks, which is one important vector. But beyond that, I think that the industry standard typically, is using OAuth 2 is a good practice on that one. But there are a lot of tricks involved in a lot of the things. So I definitely would look at that OWASP list.
Yeah, we use OAuth 2 all the time. Okay, next question. If an API has a put option, how can we make sure nothing erroneous gets put into the database, either malicious or accidental?
Yeah, so on the put, what you would also use with this platform is that you would use Pydantic as well to examine the input contents. And so similarly on this one with the query string parameters that it showed on this one, as the input comes in, Pydantic is responsible for deserializing the data from the request that they send and then converting that into Python objects. And it has a lot of validations built in. It also has a lot of customizable validations that you can perform on that one. So I think that would be where you would start with that.
Yeah, great answer. Okay, so the next question was related, I believe, to um, tip number 5. So if a value doesn't follow the type we are specifying, would it be reported as null?
So the way it would work, I'll I I don't want to give a definitive answer on that one.
Hmm.
So what I was demonstrating there is that the data is contained in our database, and before we present it to the user, that we're validating it on the way out. So um, I know that a validation error would occur inside that one. I'm not sure if that record is returned or it at all with maybe as you described, maybe with that value not included, or if that individual record is left out. So I apologize, I don't know that right off the top of my
That's
head.
cool. An area for more testing.
Yeah, absolutely.
Okay, this question's from Will. What advice do you have about actually designing the underlying data, which would also apply to non-HTTP APIs like databases and data warehouse table design?
Yeah, so the approach that I've taken with APIs and in the I'll make a pitch for my book later on this one when it talks about this one more, but in my viewpoint, I think about an API as primarily being something that's serving data from an underlying web application. And so this is a scenario that I did with the fantasy football web application, so that it's primarily a web app. It's not necessarily an API first design of it. And so in that case, really you're somewhat constrained by taking the data that's available from the web application. It's going to be relational in nature. It's going to be typically highly normalized to serve the web application. And so probably you're going to be starting with, that basically like a good web application database. You do have the ability to add additional elements to the database that aren't used, for instance, in the web application, but might serve the API. And so I'd say rather than trying to restructure the database significantly, the more that you can use the existing structure, add additional elements to it, is going to be probably the best bet for one reason, that the more effort that you put in maintaining and developing custom code for your API, the more difficult it's going to be to justify the cost of it and more maintenance. And so the closer that you can keep to your core web applications model and structure, more sustainable and economical it'll be.
Okay, great answer. Okay, I think we have a couple more questions. Another from Will. How do you recommend structuring the data response when somebody wants a data set returned that has been enhanced, JSON or JSON and CSV?
Yeah, so I think if I understand the question, it's how you said to be enhanced. So I'm not sure I totally understand the distinction you're making, but In the structure here that I was showing is that you do have at the Pydantic layer, you have full control over what you want to return. And so you're not restricted to just how it's stored in the database, but you could go ahead and maybe have some generated elements that you do, or, doing some combination or add additional ones at that Pydantic layer. It's basically, it uses the pattern of a data transfer object. And so you do design it independently from the underlying database structure. So I would say start there by focusing on what the end user needs. And in some cases, like enhancements have to trickle down into the underlying database and things like that. But the more you can do at that DTO layer, I think it probably restricts the development effort.
Next question, this is from Morpheus3353 for tip number 6. What is a polite way to ask an API developer to add a last changed date to their API?
A GitHub issue might be a good start, right? No, the communicating with I would say not even a developer, right? But really the producer of it. You want to use APIs that have a developer relations component to them. They take a product mindset. In other words, that they're viewing you as a first-class user of their application. And so with that one, it may be, you want to lean toward ones that have a formal agreement, maybe have a subscription charge in place to where, they know that they're invested in you using theirs. I would say definitely choose very carefully which APIs you integrate with. There's, they have many of them. When you go and look at their documentation, you could tell whether they have active support mechanisms, whether there's active blog posts. And I'd suggest before you actually create an integration with them that you put in some support tickets, some things like that, and see what level of investment they're in. Because in particular, if you're including it in your data pipeline, the trust factor is just so important with APIs. You need to know that when next quarterly results come and you run your pipeline or something like that, that they're going to be standing behind it.
I really appreciate that response, that putting in some tickets before you invest to see how they respond. I really appreciate that answer. Yeah. So we're really coming down to it. I actually think for some of these questions, we did have some more things here, but I think you wanted to make sure you had some time to wrap up. So thank you everybody for your questions. I think we got almost all the way to the end of the direct questions that you were asked. So please, the remainder of the time is yours.
Thanks. So I'll say, just to wrap up here, I need to give credits for my slides. First of all, the slides here from Slides Carnival template. I would really encourage everybody to focus your learning in topics like this on hands-on learning. And so presentations like this, use this as a starting point to go out and build some applications, like with real-world scenarios using this one. This is a great slide on this topic that from Forest, Brazil. And so the point of this chart is that, we all have imposter syndrome from time to time. Like, do we really have the authority that we feel like we should have from our experience and things like that? Doing hands-on project is amazing for this, is that the more time you spend building things, the less you feel an imposter on things. The more time you spend talking about it, the more of an imposter you feel, right? So go out there and create. I shared this GitHub repo, clone that and build some APIs with your own scenarios. And I would really appreciate if you could consider taking a look at my book. That's going to be released in May. It's available in early release today. And if you go to the website, handsonAPAbook.com, down at the bottom, if you're interested in keeping up as I release it and getting the email list, put your name here and email. You'll get a code for a free 30-day trial on the O'Reilly platform. It already has 6 chapters of this book on it, so you can see what's out there today. And that's a lot of resources, like all of the O'Reilly books, all of a bunch of the other books are on that one. So I would love for you to do that one and stay in touch. And I think that's it for me.
Thanks. So I just posted the link to handsonAPIbook.com again. I will also add that we have had a fair number of people that have expressed their interest in getting a free O'Reilly book. So let's you and I stay on after the call ends to
Great.
make sure we get that handled correctly.
Awesome. Thanks so much. And thanks everybody for listening today.
Thank you, Ryan. And thank you, everyone. Have a good rest of your day. Okay. We've completed the stream.